Did y'all see those hint things I put into the integrated, the Arrhenius thing? Let me show you this. So for Arrhenius, find energy of activation. This is what I did Friday because calculations were coming out so wonky. This just shows step by step how I calculated the whole thing and how I got to the answer 116 kilojoule. So look at that. I still intend to make on the test A, B, C, D, and E will be fairly different enough that if yours don't round exactly the same. But for some reason that was confusing me standing up here, so I made sure I did it in a very systematic way, and I intend to do it that way for the test, the way I do these. So look at those. I think we've done this to death, though. So that was Arrhenius find energy of activation. Find A or K. These are just, put a note here. But for that, find A or K. For the Arrhenius, just make sure over RT, just make sure this part is the correct significant figures. And then when you do the E to the X key, we should all get the same thing, and then it should round after that. I guess when you go that way, number after the decimal. When you go the other way, the number after the decimal is the significant figures. But again, just try to get it close. So what I'll do is I'll go through these last three things that I've got here. I think I did these in class, but it was weeks ago, so we haven't looked at it again. Boiling point elevation. You'll have something like this on a page to look at. It's got all the constants you need. But looking at question 1, assuming ideal behavior, what is the boiling point of the solution? So the solvent is water, so we're looking up here at water. And it's asking, what is the new boiling point? So 100 degrees is the boiling point for water. BP equals 100 C, and what we need here is the KB constant for water, which is 512. So yeah, the units are per degree C molality. So what we need is the molality. The equation is delta T, the change from 100 equals KB times the molality. That's the molality. So we have to find the molality of this. We use KB, we multiply it by that. That's the change in temperature. Then we have to apply that change to 100 degrees. So finding molality here. So sucrose is a solute. So how many moles do we have if we have 115 grams? One 15 divided by 342.34. Keep 4 significant figures. That. What else? 350 grams of water. Molality is moles of solute to kilograms of solvent. If we have 350 grams we need to turn that into kilograms, which is going to be 0.3500 kilograms of water. So now we can calculate molality. Divided by 0.3500. Delta T equals this. 0.9597 times 0.512. Delta T equals 0.491. I think I just did that. This is 0.5. This is positive because it's boiling point elevation. Boiling point. It's always true that the boiling point is elevated when you have a solvent. So the pure thing boils at 100 degrees C. It doesn't matter what the solute is. It only matters how many moles are there. So you just add 0.5 to this. So the new boiling point is going to be 100.5 degrees C. A little tedious, but it's straightforward, right? Any questions on that?
So how many questions on that should we expect in the test?
I think I'll probably do a couple of each of these that's in this list. Maybe not a couple of every one of them.
And you might have already said it, but format is mostly multiple choices?
I think I'll do all multiple choice. If it involves calculation, which almost all of them do, I'll say show your work. So you have to show your work to get credit for it, but still it's going to be multiple choice.
And this is a paper?
Paper, and I'll bring those Scantrons. Try to remember to bring a pencil, but I have a few of those too.
I'm looking at the answers, and the closest one is 104. What do you see?
It should be 100.5. Really falling down on making these questions. Elevation. I swear maybe using spreadsheets helps me, but I make dumb mistakes. Times that is 0.5. Yeah, I didn't put the right answer there. 125. Better check the next one. point depression. So I give you this again, but now we're using the freezing point, and we're using the KF instead of K for freezing. Let's not do the water. This was supposed to be benzene. Smart do these until I see them in class. See the first one. There's a freezing point of 0. Let's go on to this one. Okay, benzene. Now, so up here, benzene, the freezing point is 5.5 degrees. So we're now doing freezing point depression. It's always depression. Freezing point, 5.5 degrees C. And the KF for benzene is 5.12. Freezing point. Usually you use the star for the pure one, so I'll put the star up there. So the regular freezing point for benzene is that. And we're told the solute here, this is question number 3. No, I guess it's 4. This is question 4 for freezing points. 85.4 grams of benzene. And naphthalene is 9.64. P10H8. 10H8. Times 12 is 120, 10 times that is 10. 9.64, that's grams per mole, 9.64 grams. 1 mole is 128.18 grams. .64 divided by 128. 1.8. Pretty significant figures. All right, so the molality is moles or kilograms of this. The kilograms are going to be 0.0854. Oh, 752 divided by 0.0854 equals pretty significant figures. I guess it's 881. So that's M. That for M. For KV, we have 5.12. And that equals the change in temperature of 5.12 times 0.881. 4.51 degrees C change, and that's going to be negative because it's freezing point depression. The negative isn't shown anywhere, you just have to know it's freezing point depression. So if the regular freezing point is 5.5 degrees C, we subtract 4.5, and then we're going to have 5.5 minus 4.51, 0.9 degrees C. Benzene and naphthalene, 9.64, 28.18 moles. I've got 26.7. 9.64 divided by 128.18. Got 8.64 there. Left it at 8.64. 1.46. Have that, so what I'll do is change this to 8.64. That to 8.64. Now you see what putting in the spreadsheet does. And the answer was 1.46. Was that right? Yep. You got 0.5 numbers. I changed, instead of keeping it at 9.64, I changed it to 8.6. What did you get? It's right now. You guys work that out? If I change it, I did change it on here. So I changed it to 8.64. Now that should be right. Huh? It came out right? Did you calculate it? Alright, so if y'all see any mistakes in these, hit me up as soon as possible. But let me look at the other ones, like I did the first one. I guess I just changed numbers for these. So I just punched the wrong number in. This one's 55.8 grams. 55.8. The answer for this one, 1.27. Minus 1.27. This one, 21 grams of ethylene glycol.
I found a mistake on the Arrhenius equation A.
Which one?
The Arrhenius equation finding A or K.
Okay.
Sorry.
All right, we'll go back to that. I go over these and over these, and I think they're all correct. I still have mistakes. 42, part, 42. All right, I think the rest of those are correct. At least they match my spreadsheet. This was find A or K.
Yeah, I don't know if I did wrong there. Like I put it in the AI and cut out 3.
What number is it?
Number 4. No, it's like the
What were the temperatures here? For 157.
Rounded 3.9. Unless I'm I don't know, I thought it was something.
Did I put the hits in there for A or K?
No.
I made them, I guess I didn't put them in there. What were the temperatures?
157 degrees Celsius.
So we gotta go. Did you calculate all the other ones up to number 4?
Yeah,
Did they all come out to an answer that you saw?
like relatively.
Okay.
I might just do it wrong, but like I don't think I can.
Did you get them correct?
Yeah, I got the other.
And they all came out correct, except for this one. All right. Let's see. I'm talking to the mistake. So we're going. A over RT. 157. Did you convert the 157 to K? Did you convert it to K?
Yeah, I got 430.5.
Okay. But you should just keep 430.
Okay.
30.5.
157.
Maybe you should do 431. So that might be a source of problem. we'll use 431. R, 8.314, energy activation 2.9 times 10 to the 12. That's the frequency factor. And then finally, pH 49.2. Kilojoules, did you convert the kilojoules to joules?
Yeah, and it was like 49200.
Okay. 49200 joules, that's what we want. That's okay, it's unitless, that's in joules per mole. That's in K now. So negative EA over RT is negative 49200 over 8.314, 431. Divided by 8.314 divided by 431. And if we do this to three significant figures, we get 13.7. All right, so now I have to do this. 13.7 scientific x e to the x. I get that, but I guess I need 89000. So that equals K. 89000. 2. Did you get something like that?
No.
Because I can tell it's wrong. Is that negative 12?
No, in your problem, you said to solve the x first, so that's what I did. So I did k equals 2.9 times 10 to the 12 e to the negative 49,200 over 8.314 times the 430. But then I solved for e first, like you told us to. So
Oh, I didn't make that negative. Yeah, that's what I'm saying. Solve for this. Make sure you get the correct significant figures there.
I
and then
did,
solve.
I got 1 point.
That's what I did. I didn't put the negative on there. That's a big deal for
Yeah,
that.
I got 1.06 times 10 to the negative 6, and then I multiplied that by 2.9 times 10 to the 12, and I got like a really big number, and then I rounded to two digits in scientific notation.
Now what I'm getting instead of this, if I do this negative, is that what you got? If you put negative 13.7, I forgot the negative.
This is how I did it. I put everything into E, and then I got this, and then I rounded to one digit, so then I got 1.1.
I think that's essentially
1.05, and then I got this, and then I did it to multiply this by this, and got this, and then I was just going to do 3.1 times 6.
All right, let's see where I land. So let me do this. 1, 2, 3, 4, 5, 6. So I've got that. 2.9 times 10 to the 12. So I'm multiplying these two things now. 2.9 times 1.122 So something like 3.3 times 10 to the 6. Yeah, this is the right answer. You didn't get anywhere close to 2.9 times 10 to the 6. What did you get?
I got 3.1 times 10.
Okay.
Yeah, like that's like the number I'm trying to think I can get.
Yeah, I ended up with 3.2.
And then I also, like, if you look at all of that,
That's going to be about how many significant figures. But notice this. This is the one that's 10 to the negative 6, or 10 to the 6, so that's got to be used. When I say I'm going to make these close, this is the only one that's close by the power of 10.
Running 13.7 through the calculator, this is what we got, a couple of us.
Negative 13.
Yes.
7. Well, after you multiply, so you essentially have 3.3 times 10 to the negative 6 at the end.
Yeah. That's what a couple of us got.
Well, but look at this. This is the only one that's 10 to the 6. So you got 3.7, I got 3.8. It's not like 3.2. I'm going to try to get closer. Did you go through that one? Step by step, yes.
Yeah, it was really good.
I started to do this, so this is where I'm on EJ. Step by step, everything I did to get to the answers. I should do that. Just go. Okay, so I'll work on a guide for the blind A or K, just like I did blind for EA. But again, you're looking for something close, and I'm going to make all the answers very different. So for that one, if you got 3.2 something or 3.1 something, I had 2.9, but the only one that was times 10 to the 6 was the 2.9. So you should be able to infer that.
Do we have a quiz on everything that's on our test?
Yeah, that's everything that'll be on the test. There's one other thing I need to go over here. Do you have questions on any of the other things? This I should go over. Molarity to molality. That's the one thing I did. I've only got one question on here. Hopefully I got it. So this is molarity to molality. You've got an aqueous solution of glucose and water, concentration of 0.556 molarity. That means 0.556 moles of sucrose in 1 liter of water. That's what the 0.556 means. That's molarity. Seen that before. It tells you the density of this solution is 1.04 grams to to 1 milliliter. The solution has that density. I think that's all you're told. I put the hint in here. Assume you have 1.00 liters of solution. And we're going to need, okay, the moles. So if we assume we have 1 liter, moles of sucrose in 1 liter of, or I shouldn't say water, I should say solution here. So I've just repeated this down here, and now I'm going to say I have 1,000, 1.00 liters of solution, which means I have 0.556 moles of sucrose. Okay, so you go that direction, and then you go this direction. If I have one liter of solution, assume that, which automatically makes 0.556 moles of sucrose. And now I'm going to do up here, just to keep the units the same. I have 1,000 milliliters of the solution. That means I have 40 grams of solution. You follow those 2 steps. You assume you have 1 liter of solution. That tells you you're automatically going to have this many moles of the solute. And this is the density of the solution, so you can have find out how many grams of the solution. The solution is the water plus the sucrose. And if you have this many grams, you just need to subtract off the grams of sucrose. Then you have the grams of solvent, and then you can do moles over kilograms of solvent. So the one thing left here, I call that step 1. This is step 2, and notice in both places I'm assuming 1 liter, which is 1,000 milliliters. So I've got this for moles of my solute, this for grams of my total solution. The third step is to find moles of the sucrose. And you're told C6H12O6. .01 1.01 16 2 6 times 12.0 is 72.06. This is 12.12. What's 6 times 16? 96. 185.18. Is that right?
I got 250.
You got what?
I did it wrong.
Huh?
Oh, I did it wrong, yeah. I did 12 targets.
I want to double check. It's my answers are wrong. 6 times 12.01. I know that's 12. 16 times 6, 76. So 77.06 plus 12.12 plus 96, 85.18. Okay. So if you have that, you can go, if you've got this many moles, moles of sucrose, 185.18 grams per 1 mole of sucrose. 0.556 times 185.18 1.6, keeping three significance figures, so 103 grams of sucrose. So now I'm just going to subtract 103 from that. I'll say step 4, 1040 grams of total solution minus 103 grams of the sucrose. What's left is going to be the kilograms of water. Or grams of water. And the last step is moles over kilograms. That many moles of sucrose over 0.0937 kilograms of solvent. 1, 2, 3. No, it's 0.937. 0.937. And that's going to give you the molality. Moles of solute over kilograms of solvent. I've got 0.59 there. That one was correct. Yay. That's really the only thing I've added. Is there anything else y'all want to go over? So 1, maybe 2 of each one of these problems, exactly like they are here. I'll just change the parameters. Calculations will be exactly the same. Anything else y'all want to go over from here?
What equations, like, should we have memorized, or like, are you?
None of them. I'll give you any equation you want. Those pages of integrated and stuff, I'll give you those. I guess I could give you the freezing point, boiling point stuff, and what else? Equation for molality and molarity. And
Will we be given like the delta H, like fusion?
yeah, that. The boiling point and freezing point stuff, I'll give you that.
So we're gonna have to use
I'll give you literally that.
these three versions.
Part of the equations I'll give you is literally stapled to the back of your test will be at least these two. And then whatever else I've said I'll do.
Is there like a PowerPoint and stuff that you're giving us?
Huh?
Is there like a PowerPoint and it shows something you're giving us?
No, the stuff I'll give you on the test is what's in those quizzes.
Okay.
I mean, I did upload PowerPoints through the semester, but if you want to know what's going to be on the test, it's literally those. They'll be stated exactly the same way as they are in the quizzes. 1, maybe 2 of each one of those will make up the test.
Okay.
Any other questions? Yes.
Is there another bubble like that?
I could put some more in here this afternoon. There are some in the book. Assuming I didn't use them all. Let's see. sorry, oh my God. I'll do it, scroll down. Go away, go away. Subscription. I saw it as a joke before. Result is 11.6 mole per kilogram. Maybe I accidentally clicked on something. I don't know. Try this one too. 36. So there's two more. Let's go through these. H2SO4. So I'll put these in a PowerPoint and put the answer there with it. All right, this question is 10 molar, and it's H2SO4. In water. S, there's 1. O, there's 4. Anybody got their periodic table? What is sulfur? 32.07, 2.02, 32.07, it's 36.72, 72? Oh, times 2 is 32, so 64. 98.09. Two 2.02 plus 32.07 plus 64. 98.09. That's good. All right, we assume 1 liter. That means if we have 10 moles in 1 liter of solution, moles of H2SO4. And we have 1 liter. That means we have 10 moles. I'm going to assume that's 2 significant figures. We have 10 moles. And yeah, you don't really have to do the calculation, you just assume you have that many moles. But just to make it clear, that's step 1. Step 2. I guess step 2 was this. I guess this is step 2. You get that. And step 3. We have 1 liter moles. Oh, the density. Gave us the density. 1.84 grams per milliliter. It says 1.84 grams per milliliter for the density of the solution. And we're assuming we have 1,000 milliliters. which means we have 1.84, times 1,000, we have 1840 grams of solution. You could have done this first and then this. In step 4, I have that many moles of H2SO4. And it is 90.09 grams per mole. 1 mole H2SO4 is 98.09 grams. Times 10, that's going to be 980.9. So 980.9 grams of this is H2SO4. The rest is water. So step 5. That many grams minus 980.9. I'm keeping too many significant figures here. Should I do it correctly? It bugs me when there's only 2 significant figures. That one's 3, so no decimal there. I guess this is just 98 or 980. We're keeping 2 significant figures. The 0 does not round the 8. Maybe I'll just say 980 without the decimal. 1840 minus 980. They kept 3 significant figures, which is not correct. They should have done 10.0 if they wanted that. 860 of this. Okay, that's 860 grams of water. And 5. I'm skipping the conversion, but it's 0.860 kilograms. And we have 10 moles. 10 moles of H2SO4 to 0.860 kilograms of water. 11.6, yeah. Steal that question. I'm going to say 10.0. What's another 50 answer? 15.6. What's another 50 answer? 20.9. 2.5. So that one's in here. Want to do this next one? 1.75 molar and glycerin. Glycerin is C3H803. Three times 1648. Assuming we have 1 liter, if it's 1.75, let's say glycerin, we have 1.75 moles of glycerin. Density of the solution is 1.45 grams per milliliter. Just going to give us 1450 grams per milliliter. If we have 1.75 moles, glycerin, $92.11. 1.75 moles times 92.11. 3 significant figures give us 161 grams. 1450 grams minus minus 161. 1450 grams of solution minus the solute 161, and I got 12.89. Addition, subtraction, I end up with 4 significant figures here. That was really 3 though, so really this should be 1290. But it's not going to, my answer won't be too far off of that. So that really should be 1290, which I'm going to say is 1.29 kilograms. Keeping 3 significant figures of water. And here, .29 kilograms, and the moles was 1.75. 1.36. My calculator says 1.3565. If we're keeping 3 significant figures, it's 1.36. I'll put that in here too. to practice. All right, anything else you want to go over? Anything else you want to go over?
What type of vocab's gonna be on the test, or is it just
I
like?
don't think I'm gonna do any vocabulary. It's all kind of inherent to these problems, so I won't go crazy on it. I really am gonna do it just like the questions that are on here. Maybe there's some vocab we should go over before the ACS final at the end, because they do a little of that, but I just tend to focus on concepts and calculations.
So how many concepts calculate calculation?
If you look at what's on there, 1 to 2 of each one of those is what the test is going to be. It's giving you that. There's not going to be anything new. There's not going to suddenly be a vocabulary question that wasn't there before. It really is just going to be built straight off of those that are on there. There shouldn't be any curveballs or surprises. If you can do what's on D2L, you should be fine for the test. Any other questions? Any other questions? Stop there if there's no questions. It's all on D2L. I have to write another test today, but if I have time, I'll go through those, find A or A, give it step by step. Otherwise, just do the test, it's closed. If you're taking the test and you don't know what to say, you can ask. Oh, you're in the testing center? Just go in. I mean, I might count it wrong, and then you can just you're saying you just do 1 in 5 chance?
Yeah, or you like, we're doing the work, but it like isn't exactly right, but like you get the answer right or something, like do you get half credit, or is it like?
If I would probably just count it completely wrong, and then you can make an argument. I'll see it. Okay, you kind of got halfway there. Which ones are you doing? The ones that keep screwing up.
Yeah, I struggle with terms all the 11 movies, and I haven't taken it since like the day of so I'm just like,
This stuff is so not like 12,
yeah.
so hopefully it's for everybody. It's maybe round up.
Okay.